So now let's get to the heart of the issue. What you see on your screen right now is a basic integer array of nums, and inside the main I'm asking for and retrieving all three values of that array. No problem. But again, if that number changes, or if that quantity of nums changes, all of a sudden my workload increases as well, obviously effectively with the number that it changed to. Now if I wanted to do, I could do something simple as calculate the sum of all these numbers. Let's create a quick little sum variable. Int sum is equal to 0, and then sum is equal to nums at 0 plus nums at 1 plus nums at 2. And that'll work. I can even display it system.out print ln sum. We can run our program. Oh, we have a bit of a bug. What's our bug? Oh, I put the wrong bracket there. We run our program. Yes, I want to save. Please enter a number. Oh, I don't know. Let's say 7, 8, which is 15, and let's 5 should get 20, and our sum is 20. Great. Not the most user-friendly. We forgot a space in there, but that's all right. Just modify that really quick. A little obsessive over this, but it's okay. Alright, and that's fine. That'll work just fine until we start increasing this thing. Let's say we increase this to 10. That means that we have to do these two lines 7 more times, and we got to add in 3, 4, 5, 6, 7, 8, 9 to our sum calculation. That's a lot of work. I'm much too lazy for that. This is where loops come into play. So we are going to erase all of this, and we're just going to simply surround these two lines in a loop statement that is going to force it to loop through all the elements of our nums array. So I might say for int I is equal to, well, I'm going to write this out and then I'll try and explain this. For int I equals 0, and then I'm going to keep looping as long as I is less than nums dot length, oops, lowercase l, I plus plus. Close that. Get those lines in there. I'm going to pause on the logic inside for a second because I want to focus on the logic outside, the stuff that creates the loop itself. So I'm going to create an integer variable I, and I'm going to start at the value 0. And the reason why I'm starting at 0 is because I'm trying to look at all the elements of the array. For every element of the array, I want to ask for and retrieve that name. Well, what's the index of the first element of the array? It's 0. So I'm going to start looking at 0. What is the next one? It's 1, and then 2, and then 3, and then so forth. So I'm going to be increasing each one by 1. But notice where I stop. I stop at I is less than nums.length. Now if we call this command nums.length, it's going to give us the value 10. If I change this to a 5, it's going to give me the value 5, and so on and so forth. I can modify this, but the logic is always going to produce the correct results. So by using nums.length here instead of the actual number 10, if I decide to change this later on, the size of the array, I will never actually have to change this code down here. It will just automatically update because it's detecting the size of the array itself. Nums.length, apologize. So inside of here, what we can see is that I is going to actually hold all the values of the index elements of our array. So think about that. So I starts at 0. Add 1, it's going to have 1. Add 1, it's going to have 2. So on and so forth. And it's going to keep going as long as I is less than nums.length. So as long as I is less than 10. So that means 9. So 0 through 9. That just happens to be all the elements of our array. 0 through 9. So this is going to actually work out perfect. So instead of putting a 0 in here, I'm just going to put the value I. Because as the loop increases, or as the loop iterates from sequence to sequence, that I value is going up and going through every single possible index value. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this line of code is going to work perfectly every time. Now my sum calculation is still not doing what I want it to do because I would still have to manually go through everything. I don't want to do it like this. I'm going to do it more similar to the last example that we did in the previous video. So again, I'm going to actually just copy and paste this line because again, I want to go through every element of the array. So it's the exact same logic to iterate through every element again. That doesn't change. What changes is the logic inside. So basically, I want to take each number and add it to the previous one. So the last example that we did, we said I'll add up all the numbers from 1 to 1,000. But instead of adding up all the numbers from 1 to 1,000, I'm just going to add up all the numbers in the array. So if I start at 0 and I add the first element, let's say it's a 5, and then now that means sum is going to have the value 5. The next iteration of the loop, I add the next element. Let's say it's a 3. 5 plus 3 is 8. And it just continues on through there. So I don't need any of this. What I need to realize is that I'm adding it to the sum itself. And again, I want to look at every element of the array. So we have sum is equal to the current value of sum plus the current element of the array at index I, whatever I is, 0 through 9. And then we should get a proper answer here. Now, this is getting in this information one at a time, but let's run it. We'll do it real quick. Let's just do a whole bunch of 5s. So we're going to have 10 5s. So we should end up with a sum of 50. 5, oops, that's 58. 5, 5, 5, 5, 5, 5, 5, 5. 103 because I added in 58 instead of 5. So we get our sum. We're using multiple for loops in the same logic in order to produce the results of retrieving all the data and then summing up all the data. There are other ways to approach this, but this is an effective way. So what we need to do now is we need to analyze whether we can use this in any other more interesting ways. So for example, we can do things like nesting. So we can nest for loops, just like we can nest if statements. Basically a loop inside of a loop. We'll save that for the next video.